What are the new map and set data structures in ES6? In ES5 and below, the only data structures we had to map keys to value was an object like the one you see on the screen. I've declared an object with 2 keys and 2 values. And I can print out the value of key just by typing object.key. And there, that prints out value. And I can also use the square brackets notation to get the value of the property A. However, using objects for this does have a few pitfalls. The first one is with inherited objects. Now we've created an object called obj, which inherits from an object called base. Just a quick tip, object.create creates a new object whose prototype points to the passed in base object. If we then request a property from object and we can't find it on object, it's going to search in the base object for that property. So if I try to type here console log obj.a, you can see it prints out 1. Even though we didn't exactly declare object with a property of A, we did declare base with a property of A, and because we created object using object.create and passing in base, JavaScript first tries to see if the A property is on the object. If not, then it searches any base objects, and if base had a base object, it would go down the chain, down the chain, down the chain until there's no more base objects. But when using for in, it not only loops through the object's own properties, but also loops through the properties of any base objects. Perhaps this is the behavior that you want, or perhaps you only want to print out the keys that belong to the current object. With ES5 JavaScript, to ensure you are looking at a property of the current object and not some base object, we need to use the hasOwnProperty function like so. So if you look at the console, we can see that only the property C is being printed out. Properties A and B are now being ignored because the current object does not own that property, the base object does. So that's one thing we used to have to be very careful of when iterating over the properties of an object. An object we were just really expecting to use as a key value store. If we are using object as a dictionary, then we could theoretically store a key of hasOwnProperty as well. So for instance, if I then had let obj. So now because I've set hasOwnProperty to be my own property, which just points to 1 instead of a function, when I call object.hasOwnProperty, it's not returning a function, it's just returning the number 1. I've overridden the underlying hasOwnProperty. So now it doesn't work. Now I just get the type error, object.hasOwnProperty is not a function. And it's not a function, it's now the number 1. Another problem is with the use of the special proto keyword. Proto holds a special meaning with respect to an object's prototype chain. It's a special keyword. So we can't use it as the name of a key. When we try and use it, you can see that all that we see printed out in the console is B. It's just being silently ignored. Map is a new data structure introduced in ES6, which lets you map keys to values without the drawbacks of using objects. We create a map using the new keyword like so. We can then add entries by using the set method. But also the set method is also chainable. So the set function itself, when you call it, returns another instance of a map. So we can actually shorten all of this to just this. And we don't need those semicolons. So new map, a new instance of a map gets created. We then call set on it straight away. And because set returns a map, in fact, maybe that's easier if you wrote it like this. So we create a new instance of a map. We can then call set on it. And because set returns the same instance of a map, we can call set on it again. And we can call set on it again. And typically we would just normally put them all on new lines like so. And that's what we mean by chainable. Or we could just initialize the map with an array of key value pairs like so. So an array of arrays. So that's the first array. A1. So that's how we can initialize a map. We can extract a value by using the get method. So now if I logged map.get a, clear the console, and let's run that again. We see 1 printed out because, well, a points to 1. We can also check to see if a key is present by using the has method. And that prints out true because map has a. If we printed out D, it will print out false because the map doesn't contain D. We can also delete entries by using the delete methods. So if we call map.delete a, it returns true because, well, we deleted a. If we try and delete D, given that D doesn't exist, it prints out false. We can check for the size, the number of entries in a map by using the size property. So the map size is 3. If I was in fact to delete a, the map size changes to 2 because I've deleted 1 of the entries. And then we can empty the entire map by using the clear method. So if I call map.clear and then map.size, we have 0 printed out because we've emptied the map. There's no entries in it anymore. So how do we loop over a map? So we could use the for of, the new ES6 for of looping operator to loop over entries in a map. There are a couple of different methods we can employ. We'll go over each one and we're going to use this map as the example. Just because apple, orange, and mango are easier to say than ABC. The first method I'm going to show you is by using the keys function. So if we call map.keys, this returns the keys in the map as an array, which we can loop over using the for of looping syntax like so. Then if I run that, we'll see apple, orange, and mango printed to the console. Just the same as apple, orange, and mango in our keys of our map. We have another function we can use. We have the values method, and this returns the values in the map as an array, which again, we can loop over using the for of keyword. So instead of keys, we can call values, and let me change key to value. There we go. And so you can see in the console, 1, 2, 3 gets printed out. And this is basically looping over 1, 2, 3, the values of our key value pairs. The third method is to use the entries function. Now the entries method returns the key value pairs in the map as an array, which we can loop over again using for of like so. And there we go. So it returns an array with 2 items. The first item being the key and the second item being the value. And we can print them out to the console by calling entry with the square bracket 0, entry with the square bracket 1. But we can use what we've learned about destructuring to access the keys and values directly like so. So we can provide a destructuring an array destructuring pattern. It's a key value with the square brackets, and for each map entry that gets returned, it's going to destructure it into a variable called key and a variable called value. So we can then print out key and then value. And just like before, we can see apple, orange, and mango with 1, 2, and 3 getting printed in the console. In fact, looping over key value pairs via the entries method is so common that this is the default for a map. Therefore, we don't even need to call map.entries. If we just did of map, it would by default call the entries function. And there we go. It's now printing out apple 1, orange 2, mango 3 back in the console. And just a really important note, a distinction between object and map is that map records the order in which elements are inserted. It then replays that order when looping over keys, values, or entries. So that's why in the console it's printing as apple, orange, and mango, because that's the order in which we inserted and which we added those entries into the map. If we moved mango to the first item and then cleared the console, ran, we then print mango, apple, and orange. Another very important distinction between an object and a map. So that's the new map data structure in ES6. What is the new set data structure in ES6? Sets are a bit like maps, but they only store keys, not key value pairs. They are common in other programming languages, but are a new addition to JavaScript in ES6. So just like map, we create a set using the new keyword, like so. We can then add entries by using the add method. And just like map, the add method is also chainable. So we can just write it like so. Or just put each add method on a separate line. Or we can initialize the set with an array like so. We can check to see if a value is in a set by using the has method. Okay, that prints out true because set has apple. And does set have banana? No, set doesn't have banana. We can delete a value from the set with the delete keyword. So let's delete apple. The delete function returns true because apple did exist in the set. And we can count the number of entries with the size property. And it's size 3. And if we delete and then run it again, it becomes size 2 because we've deleted one of the items in the set. And again, if we just did set.clear, we empty out the entire set. And then set.size returns 0. And sets can only store unique values. So adding a value a second time has no effect. So if we then take the set and add apple again, it still prints out 3 because we already have apple in the set. So the second time we try and add apple, it just ignores it. And just like map, we can loop over a set by using the for of looping mechanism. And again, similar to maps, sets also record the order in which elements are inserted. It then replays that order when looping. So if I moved orange to before apple, then it says orange, apple, mango. It's replaying it in the order that the data has been inserted into the set. So in summary, map and set are a great addition to JavaScript in ES6. We no longer have to deal with map and set's poor cousin, the object, and its many drawbacks.